Hello, everybody. I hope you are doing well. And this is a review for test number 2 in Math 100. As you know, test 2 covers chapters 3, 4, and 5. Chapter 3 was on math and finance. Chapter 4 was on math and probabilities, and chapter 5 was on math and statistics. So I know you have learned a lot, and you may be just overwhelmed with the amount of knowledge and things that you have to remember. But hopefully, with this video, you can focus on what I believe is important and the type of questions that you will see on this test. All right, so I'll try to divide this up into 2 or 3 parts, but let's get started. This is the, and by the way, all I'm going to do is to go over those problems on your practice test too, okay? So the answer key is already available, but if you need extra and additional information and comments and, just the comments about how important the problems are, how to do certain steps, this video is for you, all right? So let's get started. By the way, in just a moment, I'll turn my camera off, and so we can focus on the answer key. But just so let you know, one of the important things about statistics and probability is that those concepts are applied in virtually every area, as I have been saying in my lesson videos. And one of those big areas is sports. As you know, for instance, in baseball, there's sabermetrics, where the experts, the people who are in statistics and economics even, are studying things like player performance and effectiveness of certain strategies. And so the sports is a big area where you really have to know a lot about probability and statistics now in these days. Okay, so now let's focus on chapter 3, which is math and finance. Okay, so as I mentioned here just a few seconds ago, this video is one where we will be just going over these problems in detail for practice test number 2, right? And of course, as usual, test number 2 is going to have different types of problems, but they will all come from chapter 3, chapter 4, and chapter 5. I have some extra space here that you don't see in the original practice test number 2. And you do not have to turn these things in or scan your work, not for practice test. Of course, for the actual test, you do have to show your work not for multiple choice and not for true-false questions, but for any free response questions where you have to show your work. Of course, you have to scan and submit that work. But practice test is just for you. So just work on these and make sure that you can do these problems before you go and take your test. All right, number 1, describe the difference between simple and compound interest. For example, show what happens to, okay, so you have $1,000 one-time deposit for 3 years. Okay, so let's see what happens with a simple interest. 10%. So remember here, we'll call this P of 3 because it's 3 years. And basically you have $1,000, and with a simple interest, which we really did not do a whole lot of because it's simple, and it's not very practical because most long-term deposits do not use simple interest. But it is a basis of compound interest. And so what happens is it's going to earn interest, 10% interest, right? And so $1,000 times 10%, this will be $100. And then for 3 years, okay? So this will be 1,000 plus 300, right? So this is 10% of $1,000, which is $100, times 3. And of course, you do this part first. So that's $300 in total interest. Okay, so this will be $1,300 if you are just earning interest, simple interest. Okay. All right, and then for the compound interest, I give you a formula. Now this is one of those formulas that you do have to remember. And since this is annual, there is no complicated thing here. Basically, you have 0.10 divided by 1. I didn't even have to write that because it's an annual compounding. So, I mean, technically that is correct, 0.1 divided by 1, but let me just write down 0.1, which is, 10%. And then you raise it to the power of 3 because there are 3 years and there is a compounding occurring once a year. How do I know that? Because it's annual compounding. If it's quarterly or let's say if it's monthly, then this number would be 3 times 12, which is 36, right? Because there are 36 compounding periods if this was compounding monthly for 3 years. Anyway, so this is 1,000 times 1.10 to the 3rd power, okay? And you do this part first, okay? And when you do this, you will find that this is 1,000 times 1.331, and so that's $1,331. All right, and so you started with 1,000, and so the difference of $331 is the total interest, which is more than what you got here. All right, now in the answer key, which is typed up, I show you what happens each year, for year 1, year 2, year 3, and see the difference. And that's certainly another way of doing this. But here I am just showing you what happens in the at the end of that 3-year period. Okay, number 2, when the interest is compounded 6% monthly, okay, so that means the APR, the annual percentage rate is 6%, and compounded monthly. What does it exactly mean? All right, one thing it does not mean is that you earn interest at 6% every single month, okay? 6%, if you get 6% every single month, that is a ton of money, and that's not exactly what it means. So what you have to do is you have the 6%, okay? You divide it by 12 because there are 12 months here, and so that's 0.5%. It's half of a percentage point. And that's what it means when they say 6% monthly, which is an abbreviation for an APR of 6% compounded monthly. What they mean by this is really 0.5% every month, okay? And again, this is sort of an awkward way of saying this, but that's what the financial people have decided to call this. And so, like I can't really change it, even though I don't like this kind of a misleading thing. It sounds misleading for me to hear 6% monthly, because what they really mean is 0.5% every month, okay? And it turns out if you get this in the compound interest, in the year's time, you actually get more than 6% for the year. So this is not even an accurate an APR, the annual percentage rate, but that's another story, okay? So the answer to the first part of the question is, it means 0.5% every month, okay? If you start with 1,000, okay, how much would you have after 3 years? So let's calculate this. So you start with 1,000, and then you have 1 plus, remember, 0.06 divided by 12. This is already calculated. This is exactly what I have here, except now we write this as 0.005, right? Now you raise it to the power of what? Okay, it's 3 years, 12 months a year. And so this is 1,000 times 1.005 to the 36. All right, now again, do not multiply this first and raise it to the 36th power. That would be a huge amount. You would have to do this part first. And this is what we call the correct order of operations. So remember, you put 0.005 and you do either caret or this key and then put 36. And that's going to give you this part. And then you multiply this by 1,000. Okay, and when you do this, you will get your answer, which is, let's see, I think this is going to be 1,196.68. Okay, so this part will be 1.19668, and then you multiply by 1,000, right? So you will get close to $1,200 and after 3 years. All right, so that's the answer for this question. Let's put a $sign here. Okay, number 3, what are the following formulas used for? This will be a great multiple choice question. Like in the show Jeopardy! Here are the questions. the answers. Here are the answers. What are the questions? Okay. What is the question for part A? If the answer can be calculated this way. Well, if P, this is the future amount, is 1,000 times this, right? And you can tell this is something very similar to what we just used, right? So this will be a question, how much will the balance be? Or how much is the balance? In fact, all of these are. Right? And let's say it looks like $1,000 is deposited on each of these. If the $1,000 is deposited or invested with, and then for the first part, it looks like it's 5%. And notice here you have 12, and then you have 3 here. So a 5% at, no, I should say, with 5% monthly, because the denominator is 12 for 3 years. You see that? You see where I'm getting all these pieces of information here? 5% comes from the numerator, monthly comes from the denominator, and 3 is this number, which is multiplied by the denominator. And this is 36 because there are 36 months to for this the first program, where you have 3 years monthly. Okay, look at the second part here. Now the denominator is 4, right? So the top is still 5 or 0.05, which is 5%. And what's the difference? It's quarterly. It's a quarterly compounding problem because the denominator is 4, and then 4 is multiplied by 20. That's for 20 years. Okay. Now, of course, this exponent is 40, right? What does 40 mean in this context? Well, 40 means we have 40 compounding periods because it's 4 years. I'm sorry, 80. 80 compounding periods because you have 20 years at 4 times a year. Finally, the last one, okay? As soon as you see this number E, remember this number E is like, it's an irrational number. And you have this continues on without any kind of an easy repetitious pattern, and it is, like I said, it's an irrational, what we call a transcendental number, and this E appears only in the continuous compounding formula. So the fact that you have 0.05 here, it still means that it's 5%, but it's continuously. And when you have continuous compounding, you don't have the denominator or something times something in the power, well, except the 3 here, which is for 3 years. Okay, but you don't have the number of compounding periods anymore because that would be infinite, right? If it's continuously compounding. All right, so be able to identify these equations with what kind of interest calculations are being performed. All right, number 4, you are told that the amount of your monthly payments for a new 30-year mortgage is $1,800. All right, so the payment for each payment, you have to pay $1,800. Calculate the total payment over a 30-year period. Now notice here, in homework, using that sophisticated problem or the equation, there's a huge equation, a formula that you need in order to calculate this based on things like the APR, the rate, and then if it's monthly, for how many years, and so on. That is probably the most complicated formula you have seen in this course. That particular one you do not have to memorize, right? So I will not be asking you to calculate this number. This number will be given to you, but what I would want you to remember is to find out, an answers for questions like this. How much are you going to pay over the 30-year period if you have to pay $1,800 a month for 30 years? The answer should be easy, right? Because you have this amount every month and you pay this 12 times a year and you multiply this by 30, right? You see why you're multiplying everything by, everything together? Yeah, that's because this is, what you're doing. And by the way, this is 360 because that's 360 payments you're making. And so the answer to this question is $648,000. Okay, so that's how much you are going to be paying over the next 30 years to buy this house. I believe it's a house because it says a mortgage. All right, what else do you need to know? If you want to find your total interest paid over the 30-year period, and how would you calculate your total interest? So what is, okay, so, oops, I need to bring this back here. What is the total interest paid? The total interest is equal to the total payments, which we just calculated, minus the amount of the loan. Okay, how much you borrowed. So it turns out this is the only thing you need to know, right? So for instance, you are not told here how much you could have borrowed. What is the amount of the loan? My guess is it's probably like, $400,000 or something, but it doesn't say that. So unless you know how much the loan was, how much you borrowed, how much you financed, you would not be able to answer this question, the total interest paid. But the total interest paid is very simple, right? It's a difference between how much you paid and how much you borrowed. That's very simple. So this is what you need to know. You need this in order to calculate the total interest paid. How would you calculate your total interest once you are given this information? And here is a formula. Okay, and so this is not a hard question, but that's how you would find that. And one more thing I should add is because this was already calculated for you, you do not, let's say, you do not need the APR. Okay, APR would be necessary to calculate this one. Okay, the term is already given us 30 years. And of course, you already have that. You use that to calculate here, that number here. But like I said, the rate is usually used to calculate this thing, but not the total interest. Once you know the total payment and your loan amount, the difference is how much you paid extra for the house, which is your total interest. Okay, that's the only thing you need to know for this problem here. Okay, number 5, if the principal, which is the initial deposit, is $5,000. Okay, that's one, it sounds like a one-time deposit. And the interest rate is 4%. Calculate how much you'll have at the end of 1 year if the interest is compounding annually. So remember, this is the formula that you will need to know. Depending on how often the compounding happens here. Right? So for one annually, remember we used the letter number K, and that was 1 for annually. Monthly is 12. And continuously, it just means, it's always compounding. It's sort of like K is infinity. And you don't use that infinity, of course. Infinity is actually not a number. All right, so how do you calculate this? After 1 year, the $5,000 is multiplied by 1 plus 0.04. That's 4% divided by 1, raised to the power of 1. And of course, if it's 1 year annually, 1 is the number of compounding periods, right? That's it. So you don't really do anything with this 1. You don't multiply this by anything. I mean, times 1, of course, right? And basically, this is going to be the same as a simple interest at 4%, and you will earn $200. So the answer will be $5,200. And that's because $200 is exactly 4% of 5,000. Okay, so that's not very difficult. What is a little complicated is, of course, if you have monthly compounding, then you would have to multiply this by 1 plus 0.04, that's the rate, divided by 12. Right? And then, because there are 12 months to this 1 year, you will have 12 compounding periods in this month. Okay. Now this part here, it'll be a little crazy, right? If you have to calculate this, and you can do one of those two things. You can calculate, if you know how to do this whole thing on your calculator in one shot, I would highly recommend that. If you can't, try to find out this part inside of the parentheses. I will jot this down. This is going to be 5,000 times 1.00, and then everything is 3 here, right? And then you raise it to the 12th power. So try to do this part first, okay? And so if you multiply this, raise it to the 12th power, I'm going to write down this intermediate step. This will be 1.04074, blah, blah, blah. Try to write as many digits as possible, because otherwise, you end up having an answer which could be a few $100s off, and you do not want to do that. Right? It's better to do this in one sequence of computations if possible. But anyway, you should get something close to $5,203.71. If you're off by like $1 or $2, I'm not really concerned about it, because as long as you use this formula, I know that you are thinking the right way. Continuously, okay, this is a very different formula. It's 5,000 times e to the r times time t. So it's 0.04 times 1. And so it just turns out to be 5,000. And then e to the 0.04. This is what you end up doing. And of course, if you do this in your calculator, your answer will be $5,204.05. Okay. Note that continuous compounding gives you the most amount among these. Even though all of these are with the same interest rate of 4%, this number K, it makes a difference. What kind of interest is that? Is that annual or quarterly or monthly or daily or continuously? It does make a difference. And the whole idea is more compounding happens even with the same amount of time. The more frequently the compounding happens, the more money you would be making, because you can see this is the highest here. This is the second highest, and this is okay. All right, number 6, suppose you're financing $500,000 in a home mortgage. If the interest rate is the same, in what type of mortgage would you be having higher monthly payments? Okay, 15-year or 30-year mortgage, assuming that the interest rate is the same, right? What do you think? This is a common sense problem. Would you be paying, every month, would you be paying more if you have a 15-year mortgage or a 30-year mortgage? Right? The answer is 15-year mortgage. Now, you know the 15-year mortgage saves you lots of money, right? But that's because the time is short. And the answer that it's going to cost you more every month is because it's shorter, right? And so you know what 15 times 12 is? That's 180 payments. So in a sense, you are borrowing the same amount of money, but you're trying to pay this back in 180 monthly payments. And of course, you have to pay more every month. But the good thing is, after 15 years, you're done. Okay. Now, 30-year payment mortgage is going to be cheaper every month, but it won't be half. Okay, it'll be a lot more than half of the monthly payment for a 15-year mortgage, and it's much longer. Right? But I hope you understand why every month you have to pay more if the term is short, just because you're trying to finish the whole mortgage in a shorter amount of time. All right, and so that's part A. And how about part B? Part B, the total interest paid. In which type of mortgage would you have higher total interest over the term of the loan? And the answer is undoubtedly the 30-year mortgage. Because it's longer, all right? And remember, compound interest works against you if you borrow money, especially for a long period of time. And so because of the interest and because of the way the interest accumulates over a long period of time, if you have a 30-year mortgage, you will be paying a lot more in general. Even at the same interest rate, you will be paying a lot more in interest than in a 15-year mortgage. Okay, so, and again, you can do all kinds of detailed analysis here if you know the amount of the loan and the APR, and, assuming it's compounded monthly. But I will not be asking you those questions like, coming up with exactly how much you have to pay every month and so on. Okay, that requires that one very complicated formula. Right? But I will ask you questions like this, because these are the things that you can take. Those are like takeaways. These are the things that you should know for the rest of your life based on what you learned, based on the homework problems you did. And these are more of a common sense questions, and you do need to know these. Okay, I believe we have one more question from chapter 3, so let's do that. And then we'll pause and then go to the next segment or the next part of this video. All right, so Mark has a great credit score and John does not. Okay, Mark has a better credit history than John. John messed up somewhere. Okay, but that's okay. I mean, you know, you have time to fix. But it's unfortunate for John if they're about ready to buy a house or a car or something, because Mark would qualify for a better financing opportunity. They both finance $300,000 to buy a house. Okay, Mark gets a 30-year mortgage with a monthly payments of $2,000. John, of course, only gets higher. I mean, it doesn't say, but he gets a higher rate. And so he doesn't qualify for as good of the an APR, the rate. And so John ends up paying, he says, the best I can do for you is $2,200 a month. Okay. And so they're thinking, John's thinking, okay, well, it's $200 a month. I have to pay extra. That's too bad, right? So the question is, calculate how much extra John will be paying over Mark. I guess this word is missing. Over Mark, the term during, or I guess you can say, calculate how much extra John will be paying over Mark, that's assumed, over the term of the mortgage, which is 30 years, okay? So the best way to do this is just find the monthly difference. How much, you know, how much more is Mark paying, or how much less is Mark paying compared to John? And the answer is, of course, 2,200 minus 2,000, it's $200. Okay, remember, this is per month. Okay, John is paying $200 a month. Not a big deal, maybe, right? But it is a big deal if you do have to pay this 12 times a year for 30 years. Okay, in other words, you have to make that difference happens 360 times for this mortgage, because you both are paying 360 payments, right? Making 360 payments. So the answer is 200 times 360, and it turns out to be $72,000. Okay, so here's the statement to conclude this part. John is going to end up paying $72,000 over the 30-year period as compared to Mark, who has better credit, right? And only because the credit score is different, John is not qualifying for a good interest rate. And in his lifetime, he will be paying $72,000 more than Mark for the same amount of loan, right? The moral of the story, don't mess up your credit score, okay? Be faithful when you have to make payments for credit cards or rent or whatever now, okay? So that you will not be facing this kind of a problem. All right, I think that will do for the chapter 3. Next time in part 2, we'll be talking about chapter 4, the probability chapter.